this video, I'll present key features of correlation for predictive analytics. So one of our objectives is to show the existence and the strength of a relationship between a pair of variables. These could be any two variables of interest, and not necessarily a cause and effect relationship. For example, height and weight are related. Taller people tend to be heavier than shorter people. Although the relationship isn't exact, it's not perfect, on average it may exist. In predictive analytics, this can be used for investigating relationships between any two variables of interest, anything we can plot along an x and y axis. So we want to look to see, well, does a relationship exist, and how strong is it? And if you know the inputs and outputs, you may be interested in finding which x's have significant relationship with which y's. So correlation does not look for cause and effect. We're just thinking of it as relationships of proportion at this point. So when evaluating scatter diagrams, you need to analyze three characteristics: direction, form, and strength. A line of best fit or linear regression line passing through a set of points in a way that minimizes the distance or residuals between the points and the line. We want to plot something that's relative, that fits these points or goes through these points relatively in the middle. So in a naive explanation, well, we want a line that goes through the middle of the points. So the direction of the line tells us if the correlation is positive or negative, if the x and y variables are proportional or inversely proportional. The form of the line, say a straight line, it doesn't have to be straight. It can be a concave line or a convex curve or a polynomial curve that has a few peaks and valleys. So that tells us about the complexity of the relationship. And the strength of the line is just the steepness of it, or the slope.